Welcome to our comprehensive guide on backend programming languages and web fundamentals. In this video, we'll explore the essential concepts that power the modern web, from the basics of the internet and the World Wide Web to the protocols and structures that enable seamless communication. Whether you're a beginner or looking to refresh your knowledge, this journey will help you understand how web applications interact, how data is transferred, and why APIs are so crucial in today's development landscape. Let's start by unraveling what the web really is and how it connects people, businesses, and information worldwide. Internet is a vast network of interconnected computers, owned by organizations like businesses, governments, and educational institutions. It provides services such as email, real-time chat, and remote access. The World Wide Web, or simply the web, is a collection of information resources and services that live on the internet. Think of the internet as the infrastructure, while the web is the content and services you access through browser. Each website consists of web pages, often containing multimedia and hyperlinks, allowing users to navigate a web of information. Understanding this distinction is key to grasping how web applications function. Organizations often use intranets, private networks accessible only to their members, for internal communication and resource sharing. To protect these networks from unauthorized access, a firewall acts as a barrier between the intranet and the broader internet. Some organizations extend limited access to outsiders through an extranet, which allows authorized external users to connect via the internet. This layered approach ensures security while enabling collaboration beyond organizational boundaries. Understanding intranets and extranets helps clarify how businesses manage internal and external communications securely. Several foundational technologies make the web work. HTTP, or Hypertext Transfer Protocol, is the standard for transferring web pages. HTML, or Hypertext Markup Language, formats documents for the web URLs or uniform resource locators, specify the location and access method for resources online. These technologies work together to allow browsers and servers to communicate, display content, and enable navigation across the vast landscape of the web. Mastering these basics is essential for anyone working with web applications or APIs. HTTP, or Hypertext Transfer Protocol, is an application-level protocol designed for distributed collaborative hypermedia information systems. While it was originally created for communication between browsers and web servers, HTTP is now used for many purposes, including machine-to-machine communication and API access. One of its defining features is statelessness. The server does not retain session data between requests. This simplicity and flexibility make HTTP the backbone of web communication. HTTP transaction involves several key steps. First, the client establishes a connection to the server, typically using TCP. Next, the client sends a request for information. The server processes this request and responds with the requested data or an error message. Finally, the connection is closed by either party. Each transaction is independent, and all data is transmitted in human-readable ASCII text. This structure ensures reliable and efficient communication between clients and servers. Connection phase of an HTTP transaction begins when the client connects to the server using a TCP connection, usually at port 80. The translation of the server's address into a numeric IP address is handled by lower network layers. TCP ensures reliable delivery by breaking down large requests and responses into manageable chunks. Once the dialog is complete, the connection is closed. All HTTP data is expressed in readable ASCII text, making it easy to debug and analyze. Simple HTTP transaction starts with a DNS lookup, where the client resolves the domain name to an IP address. The client then establishes a TCP connection with the server. After the connection is set up, the client sends an HTTP request and waits for the server's response. The server processes the request, finds the resource, and sends back the response, which the client loads. Finally, the connection is closed. This process is the foundation of how browsers retrieve web pages. Serial HTTP connections: multiple requests are made sequentially to a server, with each request establishing a new connection. For each request, the client performs a DNS lookup, establishes a TCP connection, sends the HTTP request, waits for the server's response, and loads the content. This process repeats for each new request, making it straightforward but potentially less efficient for multiple resources. Persistent HTTP connections allow the client to reuse the same connection for multiple requests to the same server. After the initial DNS lookup and TCP connection, the client can send several HTTP requests and receive responses without repeatedly opening and closing connections. This approach improves efficiency and reduces latency, especially when loading multiple resources from the same server. HTTP 1.1 browsers can open multiple connections to server and perform HTTP requests in parallel. This capability allows for faster loading of web pages by fetching resources simultaneously, rather than waiting for each request to complete before starting the next. Parallel transactions are especially beneficial for complex web pages with many assets like images, scripts, and stylesheets. HTTP request message consists of four main components: the request line, headers, an empty line, and an optional message body. The request line specifies the methods such as get, post, put, delete, the resource URI, and the HTTP version. Headers provide metadata about the request, such as content type and authorization. The body, present in post and PUT requests, carries data to the server. Understanding this structure is crucial for building and debugging web applications. HTTP defines several methods for interacting with resources. GET retrieves information, POST sends new data, PUT updates or replaces existing data, and delete removes resources. Each method serves a specific purpose and is used according to the desired action on the server. Choosing the correct method ensures proper communication and resource management in web applications. Request URI identifies the resource upon which to apply the request. It can take several forms: origin form, the most common, like absolute form used with proxies, asterisk form for server-wide options, and authority form used with the connect method. Understanding these forms helps in designing flexible and robust APIs. Headers and HTTP requests carry important metadata, such as the host, content type, authorization tokens, user agent, accepted languages, and connection preferences. These headers help the server understand the context and requirements of the request, enabling features like authentication, content negotiation, and persistent connections. Proper use of headers is vital for secure and efficient web communication. Request body is used to send data to the server, typically in POST and PUT requests. The format of the body is specified by the content type header and can include JSON, XML, or raw text. For example, submitting a form or uploading a file involves sending data in the request body. The server processes this data to create or update resources. When a server receives and processes a request, it sends back an HTTP response. This response includes a status line with HTTP version, status code, and status text, headers, an empty line, and an optional body. The status line indicates the result of the request, while headers provide metadata about the response. The body contains the requested data or error details. HTTP status codes are 3-digit numbers that indicate the outcome of a request. The first digit categorizes the response: 1XX for informational, 2XX for success, 3XX for redirection, 4XX for client errors, and 5XX for server errors. These codes help clients understand what happened and how to proceed. For example, 200 means OK, 404 means not found, and 500 means internal server error. Commonly encountered HTTP status codes include 100 continue, 200 OK, 201 created, 301 move permanently, 400 bad request, 401 unauthorized, 403 forbidden, 404 not found, 500 internal server error, and 503 service unavailable. Each code provides specific information about the request's outcome, guiding clients on next steps or troubleshooting. Response headers provide additional information about the server's response, such as content type, server details, authentication requirements, and caching instructions. These headers help clients interpret the response and manage subsequent requests. For example, the location header indicates redirection, while www authenticate prompts for credentials. Response body contains the actual data requested by the client, such as HTML, JSON, XML, or other formats. In successful requests, the body delivers the resource, while in error cases it may provide details about the issue. The format and length of the body are specified by headers like content type and content length. Modern browsers provide local storage and session storage to allow web applications to store data locally on the user's device. These mechanisms enable applications to remember user preferences, settings, or temporary data, enhancing user experience and performance. Let's explore how local storage and session storage differ and when to use each. Local storage allows websites to store key-value pairs in the user's browser, with a capacity of up to 5 MB or 10 MB depending on the browser. Data persists even after the browser or tab is closed, making it ideal for long-term storage of preferences or settings. However, developers should avoid storing sensitive information in local storage due to security risks. Local storage provides 4 main methods: set item key value to store data, get item key to retrieve data, remove item key to delete a specific entry, and clear to remove all stored data. These methods make it easy to manage persistent data within the browser, supporting features like user preferences and application settings. Session storage is similar to local storage but with a key difference: data is only stored for the duration of the session. When the user closes the browser tab or window, the data is deleted. This makes session storage ideal for temporary data such as form inputs or shopping cart items that should not persist beyond the current session. Session storage offers similar methods as local storage: set item key value to store data, get item key to retrieve it, remove item key to delete a specific entry, and clear to remove all session data. Each browser tab or window has its own session storage, ensuring data isolation between sessions. API or Application Programming Interface is a set of definitions and protocols that allow different software components to communicate. APIs act as mediators between clients and resources, enabling integration and interaction across applications. They define how requests and responses should be structured, making it easier to build and connect software systems. REST, or Representational State Transfer, is a software architecture for designing networked applications. REST-TFL APIs use HTTP methods to perform actions on resources and are characterized by statelessness. Servers do not retain client data between requests. REST-TFL APIs are scalable, flexible, and independent of the underlying technology, making them a popular choice for web services. APIs offer several advantages. They are highly scalable, as statelessness reduces server load. Their client-server separation allows different components to evolve independently, and their technology independence means you can use any programming language for the client or server. These features make REST-TFL APIs ideal for modern, distributed web applications. REST-TFL APIs are built on several key principles: uniform interface, statelessness, layered system, cacheability, code on demand, and client-server separation. These principles ensure consistency, scalability, and flexibility in API design, making REST-TFL APIs robust and easy to maintain. Uniform interface is fundamental to web services. It means that information is transferred in a standard format called a representation. This format can differ from how the server stores data internally. For example, data might be stored as text but sent as HTML or JSON. A consistent interface simplifies client-server interactions and promotes interoperability. Statelessness means that each client request is independent and contains all the information needed for the server to process it. The server does not retain any session data between requests. This approach simplifies server design, improves scalability, and makes APIs easier to maintain and cache. Layered system allows clients to interact with intermediaries such as proxies or gateways between themselves and the server. These layers can handle security, application logic, or business rules and remain invisible to the client. This architecture enhances scalability and flexibility as each layer can evolve independently. REST-TFL web services support caching, allowing clients or intermediaries to store responses for faster access. For example, common images or data can be cached after the first request, reducing server load and improving performance. API responses indicate whether they are cacheable, helping clients manage data efficiently. REST servers can temporarily extend client functionality by sending executable code such as JavaScript. For instance, when you fill out a form online, the browser may highlight errors instantly thanks to code sent by the server. This principle adds flexibility but is optional in REST-TFL API design. The client-server principle enforces a clear separation between the user interface client and data storage or processing server. This separation allows each component to evolve independently, improving maintainability and scalability. It's a core reason why APIs are so adaptable and robust. REST, a resource, is any information that can be named and represented, such as documents, images, or collections. Each resource is identified by a unique URI, Uniform Resource Identifier. A URL is a type of URI that also specifies how to access the resource. Proper resource identification is the foundation of effective API design. When designing URIs for APIs, use nouns instead of verbs, prefer plural nouns for collections, and represent relationships hierarchically. Use lowercase letters and hyphens for readability, and maintain consistent nomming throughout your API. These practices make APIs intuitive and easy to use. Resources in REST APIs are typically represented in formats like JSON, XML, or plain text HTML. The representation captures the current state of the resource, which clients can retrieve or modify. JSON is widely used for its simplicity and compatibility with JavaScript, while XML and HTML are also common in various contexts. Stateless API does not rely on the server to maintain client session state. Each request contains all necessary information, making the server's job simpler and improving scalability. Stateless APIs are cacheable and compatible with various systems, but may be less efficient for applications requiring frequent, small requests or real-time updates. API versioning is the process of managing changes to an API without disrupting existing users. It allows developers to introduce new features or breaking changes while maintaining compatibility for current clients. Versioning can be implemented through URLs, query parameters, headers, or media types. There are several ways to version APIs: URL versioning, adding version to the path; query parameter versioning, header versioning using custom headers; and media type versioning using the accept header. Each method has its pros and cons, such as ease of use, clean URLs, or implementation complexity. Choosing the right method depends on your API's needs and client expectations. Error handling in APIs involves identifying and responding to errors in a way that helps clients resolve issues quickly. REST APIs use standard HTTP status codes to indicate errors and provide detailed messages in a consistent format. Proper error handling improves the developer experience and makes APIs more reliable. REST APIs typically use three types of error handlers: catch for unhandled exceptions, timeout when a response takes too long, and failure for errors not caught by the other handlers. Each handler routes the error to the appropriate response, ensuring that clients receive clear and actionable feedback. Pagination is the process of breaking down large datasets into smaller, manageable chunks that can be fetched incrementally. This approach improves performance and user experience, especially when dealing with vast amounts of data. There are several types of pagination, including page-based, offset-based, cursor-based, and keyset pagination, each with its own advantages and use cases. Page-based pagination uses page and size parameters to navigate through data. For example, requesting page 2 with a size of 10 returns the second set of 10 items. This method is simple to implement and user-friendly, but can become inefficient with very large datasets. Offset-based pagination uses offset and limit parameters to fetch data, similar to skipping chapters in a book. For example, offset equals 20 and limit equals 10 skips the first 20 records and returns the next 10. This method integrates well with SQL queries but can become inefficient as the offset increases. Cursor-based pagination uses a unique identifier like a UUID to mark the starting point for the next set of items. This method is more efficient and reliable for large or frequently updated datasets as it avoids performance issues associated with large offsets. Keyset pagination, or the seek method, is ideal for large or frequently updated datasets. It uses a sequentially ordered key, such as an ID or timestamp, to paginate through data. This approach provides consistent performance and replicable results, regardless of dataset size or update frequency. This video we explored the foundational concepts of web communication: HTTP transactions, request and response structures, browser storage, REST-TFL APIs, error handling, and pagination. Understanding these principles is essential for building robust, scalable, and efficient web applications. As you continue your journey in backend programming, keep these concepts in mind to design better APIs and deliver seamless user experiences.